All right, let's do some experiments. We are live. Got a little stir bar going with a magnetic stir plate over here on the left. We are going to add some universal indicator to our flask on the left. See what this looks like. It's kind of pretty. There we go. And it goes. You can see the material pretty much stays concentrated in the center vortex. And then slowly it'll get diffused out over the entire flask. Yeah, that stir speed's on pretty fast, which means the material gets diffused out fairly quickly. Let's go another one. And then I'm going to get a little water on the going in the one on the right. I think that looks nice. That green color from the universal indicator, that tells us that the pH of our water over there is neutral. Here, I'll show you the, here's the different colors that you'll see with the universal indicator. Oh, that's the wrong one. That's cabbage indicator. Here's your universal indicator. Oh, looks like it's a little messed up. I'm going to have to reprint this, but our pH is at 7 over here, so that's neutral water. We're going to put a little bit of water over here on the right, and then we'll add some universal indicator. I'll let you see what this looks like. You can see there's a stir bar already stirring down there at the bottom. Let's pour some water in. We are doing science there, pro at Minecraft. In goes the water. Thanks for joining along tonight. Well, it's evening here for me. I don't know where it is for all of you that are watching. But it is about 6 p.m. in the evening where I'm at. And we're going to do some science here. Little science experiments. I'm going to get this just a little bit more water. I like to have them right about the same height. Just a bit more. And over there on the right, the stir bars are the same size. It just happens that the stir bar on the left is rotating much more quickly. I turn it up down here at the bottom. And so this is just barely spinning. So you just get a tiny vortex here. We're going to see what the difference is when I put in the universal indicator over here on the right. We'll probably see a difference with how long it takes for the material to get, incorporated into the fluid. And this stuff that I've added, it's slightly acidic. So over here on the right, it's going to look red. Boy, look at that. Isn't that gorgeous? Look at that. There's just a lot going on there. As that red material gets spread out into the surrounding fluid, it should start to look a little more green. All right, let's see here. Let's get a little bit more in over here. Isn't that cool? We get two colors there. The red from the acidified indicator, and then when it meets the material from the water, kind of goes to a green color. That's really beautiful. Isn't that a beautiful effect? That's really cool. Oh, that's gorgeous, man. Look at that. Come on, that's cool. Yeah, Josh, it's it's just goofy looking, isn't it? I have looked up an article on the fluid dynamics of the water that's being stirred on a magnetic stir plate, and indeed there is a stable flow that you get straight down the center of the vortex, which is clearly what we're seeing. Up here at the top, you can see I'm going to add some more material, and you can see now it's as I'm adding it in, it's getting it's fairly neutralized. But look at that; it just looks like a tornado, man. Look at how stable that flow is. It's really cool. Really cool. Those colors aren't quite the same. Help, what is that? So what I've got in these flasks is some water. And to the water, I've added a special mixture of chemicals called universal indicator. And universal indicator is going to display different colors at different pH values. And the different pH values that we'll see will run from 3 to 10, and it'll follow the colors of the rainbow. You might know who Roy G. Biv is if you learned your rainbow colors back in grade school. We start at pH 3, which is very acidic, on the acidic end. And then as the pH increases, the acidity drops. I know that's backwards, but it's true. As the acidity goes up, as the pH goes up, the acidity drops, and it becomes neutral at pH 7, which is green. And then when you see the aqua, blue, and violet, that's alkaline or basic. So what we're seeing over here, you see that red material there on the right? Inside the vortex is low pressure zone, limiting the diffusion, just like the high of a hurricane. That's right, Josh. That's really cool. That's a great way to put it. Thank you for that, Josh. Indeed. So, it's gone now, but we did have a slight bit of red material there, which told us that the center of the vortex was like a pH of 3, whereas the surrounding material was neutral. So what I'll do is I'll add a drop of acid, hydrochloric acid, the same acid that's found in your stomach. It's just this is a lot more concentrated. I'm just going to add it to the center of the vortex over here, and we should see some stable red. You see it there? Yeah, you get a nice stable red, of course, as it flows down and acidifies the entire material. We get a shift to a red color. I'm going to turn this flow down here over here. On the other side, I'm going to add some base, alkali. Well, it looks like a sunset, huh? Okay, so over here on this side, we're going to add base instead of acid. And we should see a different effect. Over here we go. In goes the base, sodium hydroxide base. And sure enough, we see a shift to a blue color. So over here now we have base, alkali. Over here we have acid. I'm going to add just a little bit more acid over here on the right. I added base. Oops. I added base. That's what the blue color is there for, but we're seeing some gorgeousness over there, so I'm just going to let it ride. How you doing there, Timothy? Thanks for joining in. All right, let me go ahead and acidify. Let's make sure I'm to what I'm adding. Nope, that's base as well. Come on. Come on, Tommy. Let's add the right stuff over here. How you doing, Fire? All right, here we go. Add some acid over here. You can see that the acid pretty much stays concentrated in the center, and then it kind of gets spread out as the vortex gets pushed off to the side. So over here, how you doing there, Jake? Jacob Dale. So over here we have an acid. Over here we have a base. Just to remind you, these are the different colors that you're going to see at the different pH values. You're going to see, let me get this light on so we can see it just for a bit. So you're going to see pH 3 will be red. That's acid. 4 and 5 and 6 are also acid. And then at green, it'll be neutral. And then above 7, it'll be basic. So what we're going to do now is we are going to add let's add acid to the base, and let's add base to the acid. So we're going to do base over here first on the right. So I'm going to add some sodium hydroxide base to the hydrochloric acid. They'll just do like 3 drops. And let's watch what happens. You see the violet and blue down at the bottom. And as the acid and the base, I'm going to add some more base up here at the top. As the acid and base react, they neutralize each other. And if there's more acid, it'll remain red. If there's more base, it'll shift to a blue. And if they're perfectly balanced, we will end up at green. Yeah, Jake, anyone can do this stuff. You just need water, a stir plate, and some universal indicator, and some sodium hydroxide and hydrochloric acid. It's pretty simple to do. I'm adding more base over here on the right. So someone didn't get the same salting out effect. 40 grams of what per 100 mils of DI water? So, Selmitos, what I normally do, look at that over here on the right. So you use regular salt. Okay. What I got over here on the right is completely neutralized. So I added base to this, which neutralized the acid. So, Selmitos, what you're going to want to do is the ratio is, off the top of my head, it's going to be, oh gosh, I hope I remember this. It's 16 grams of water, 16 grams, be careful here, of 70% isopropyl alcohol. So that's 70% isopropyl alcohol and 70%, or excuse me, 30% water. And then to that, you're going to add 4 grams of your salt. You know, wait a minute. That's not quite right. That's my potassium carbonate. Over here on the left, by the way, I'm adding some acid. So you should see the color shift to a red. I'm doing this off the top of my head there, Selmitos. So give me a little grace here. Okay, so what I do, okay, yeah, for the salt, when using sodium chloride, I use 240 milliliters of water and then 280 milliliters of 91% isopropyl alcohol. That's the kind that we can get in the drugstore over here in the United States. And then to that, you're going to add 50 grams of salt. Sodium carbonate, Selmitos, I have trouble with. But potassium carbonate, I can give you, I'm adding acid over here on the right. Potassium carbonate, that recipe is a little different. That's the one where I do 16 grams of water, 16 grams of 70% isopropanol, and then 4 grams of potassium carbonate. Yeah, let me know, bud. Let me know, Selmitos. I'll be looking for you. You know, comment on that video. It'll be nice to see how things work out for you. Where can you buy a universal pH indicator? More Lube, I get mine online. I just look up a universal indicator and just, you know, do some searching, and you can find that stuff on Amazon. So both of these are acidified now. They're both quite red. pH is low, so I'm going to add some base to each. I'm going to go 5 drops over here and 5 drops over here. I'll let you watch the beauty, and I'll check out the comments. Boy, that's pretty, isn't it? So again, if I've added more base, the mixture will look kind of blue when the reaction's done. If I've added more acid, it'll be like a yellow, orange, or red. And if I've completely neutralized it, like it looks like I have over here, it's going to be green like this. This one's still slightly acidic. I made one using thymol blue. Would it be considered as universal? Yeah, thymol blue works pretty well as a universal indicator. They modify that just a bit to get the other colors, but thymol blue works quite well. Over here on the left, I'm going to add a bit of base to see if I can't neutralize the remaining acid. You can see the violet color grow in. And it looks like this is slightly acidic, so I'm going to add another drop of base over here, see if we can't get that to green. Look at that beautiful swirl. How you doing there, EP1000? Welcome. Welcome to the live. I'm just doing some experiments. Glad you joined. I'm answering any questions that folks have about different experiments that I do on my channel, and just, you know, I like to do some chemistry at the same time. I'm adding base to the flask on the left. Looks like this has been neutralized over here. I'm going to go ahead and make this basic by adding a bunch of base over here on the right. And it looks like it's slightly basic over here. So I'm going to add some acid over there. See if we can't acidify this. Maybe try adding a buffer to one at the same pH. Sure, we can do that, Josh. How old am I? I am going to be 56 in my birthday, which is next month. I'll be 56 years old. I'm an old man doing experiments in my basement. What could you use as a buffer? I'm going to show you there, Selmitos. Check this out. So, I use this in class. I don't know if any are chemistry teachers or science teachers out there. If so, please let me know in the comments. It's always a thrill to know if folks are, using my stuff. But this is what I'm going to use as a buffer. I'm just going to use an effervescent. Let me turn this on so you can see. I'm going to use an effervescent cold relief tablet, an Alka-Seltzer. So I'm just going to take an Alka-Seltzer tablet, all right? And we're going to drop it in here. I want to get them both to the same pH. So this one, I'm going to get just a bit more basic. So I'm adding base to the flask. On the left, I'm going to add acid to the flask on the right. Oh, look at that gorgeousness. It's so pretty. I want to get these both a roughly yellowish color. And then I will add the effervescent tablet to the flask on, we'll do it to the flask on the right. Let's get another drop in there. Okay, here we go. Let's make a buffer. Let's make a buffer. So in goes the tablet over here on the right. Here we go. You can see it effervescing. You can also see it's like imparting an acidic nature to it because we can see the red coming off of it. Now that's from the aspirin that's in the effervescent tablet, which is an acid. But there's also a chemical reaction that's going on. We can see the chemical reaction as the tablet fizzes. That's actually a reaction between citric acid and sodium bicarbonate. And the reaction between the citric acid and the sodium bicarbonate is going to form carbon dioxide, which is making the bubbles that you can see, but it's also making a lot of sodium citrate. And so what we're actually forming here on the right is a citrate buffer. So you can see that red color that initially develops. It's kind of fading to like a yellow color, which indicates pH of around 6. I'm going to go ahead and drop this in here. We'll let it react the rest of the way. And, you see a bit of red as the acidic aspirin dissolves into the material, but as that reaction between the sodium bicarbonate and the citric acid continues, we get a lot of sodium citrate, and that's going to form our citrate buffer. So now this material over here is buffered at a pH of roughly 6, and this is an unbuffered solution. And so I'll go ahead and we'll add like 3 drops of acid to both. So here we go over here on the left. We're going to do 3 drops of acid to the unbuffered solution, and we'll do 3 drops of acid to the buffered solution. Now let's watch what happens. It's a pretty big difference, isn't it? Drink Vortex water. Not going to happen, B. Hendricks. One of the indicators in here is a laxative. That's going to ruin the live if I drink this stuff. But yeah, you see the huge difference. I added acid to the unbuffered solution. The pH changed dramatically. We went from a pH of 6 to a pH of 3. That's 3 pH units. That's 10 times 10 times 10. So this had a change in acidity of 1,000 times, and this was, a minuscule change in acidity. Now to both, I'm going to add 10 drops of base. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see what happens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the one on the left started red. The one on the right started yellow. And we went from a pH of 3 to a pH of 10 on this side. That's a pH change of 7, which is 10 times 10, 7 times. That's a change in acidity of 10 million over here. On this side, it's still yellow, isn't it? So we see the buffered solution resist changes in pH. Yeah, absolutely. It's going to require a bunch more on the Alka-Seltzer to increase the pH. I'll go ahead and add 10 more drops. Let's see if we can get to go a little bit green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see if we can get a little green color over there. Or is the buffer just going to keep it at pH 6? I know some chemistry, but why does the buffer do this? Great question, Morlube. So what's going on in the buffered solution is it is a little bit more green. I'm going to add some acid over here so you can watch something on this side while I talk about this. And I'll add some acid to the buffer as well. So a buffer is going to contain both a weak acid and its conjugate base. What that means is it's something capable of donating protons. That's the acid. And it contains something capable of accepting protons. That's its conjugate base. And the interesting thing about an acid and its conjugate base is they don't react with each other. So usually when you mix an acid and a base together, the acid and the base react and they neutralize each other. But what's interesting about a buffer is by adding the acid and its conjugate base, that's right, Selmitos, there's a bunch of buffers in our body. When you add an acid and its conjugate base, you have added an acid and a base to the system that will not react and neutralize each other. And so that's what I have over here is a buffer on the right. I'm adding the base to it. And therefore, the addition of base to this will be consumed by the acid in the buffer that's present, and the addition of acid to this buffer will be consumed by the base that's present. That's pretty much how a buffer works. Well, there you have it. I think that's been a nice little live. We've been going about 20 minutes. I think that's good for the evening. I appreciate you all being here and asking some questions, and let me know you've been checking out some of the videos that I've got on my channel. Yeah, Sell Me Toast, I appreciate that. I'll be trying to do some of these lives, usually Friday, Saturday, Sunday, sometimes around then is when I'll do the lives. I like to talk to, some of my people who hang out. If you don't subscribe, I encourage you to check out my channel. And if you like it, maybe consider giving me a subscription. And spread the word. I'm trying to get to 500,000. We're getting there, folks. We're running around a little over 400,000 subscribers, which blows my mind. I got to be honest with you, but that's a real thrill for me. So if you do subscribe, thank you for doing so. I really do appreciate it. And if you'd spread the word and, send my videos to people who get a kick out of goofy science experiments or a little bit of chemistry and learning some chemistry, send the word on. And thank you there, Sell Me Toast. I appreciate that. And yeah, if you if you like the live, send me a hello on one of my videos. All right. So thanks for joining in, and we'll probably see you again next Friday. Thanks, folks. So long.